All right, so today's office hours, just going to start with talking about presentations. These presentations will look quite a bit different from our last presentations because our last presentations were just pretty much just the EDA portion of a project. So the last presentation, we're just presenting insights and presenting recommendations to Microsoft for their film streaming service. But for this one, we're actually training a model. We're using a model to create predictions, which is more of a full data science process project. So the slides inevitably are going to look a little different. So I'm going to first walk through a template, and the template again is not the only way you can do a presentation. I'm going to walk through a template and then walk through a student example, and you'll see the little changes or like the little parts that are different from the template. So to start, a lot of this I've literally copied over the slides from the first one and just made a couple changes. So project title, pretty self-explanatory. The second slide, your business case, your why, your motivation. Ours for this project should be pretty similar, but for the most part, yeah, you're creating a model to predict prices, but try and go at least one step beyond that. Predicting prices for what? Like, are you looking to, flip houses? Are you looking to, maybe you own a property there and then you want to see what features on average affect housing prices, something like that, something along those lines. Try to go just one step beyond, creating a prediction model. And then possibly a preview of your results. The student example I'm going to show in a little bit actually does this. What some presentations do for data science, especially when you're building a model, right at the start, they're like, and with this project, I created a model to predict the price of a house using these features with however whatever metric accuracy. So that is something that you could do depending on the way that you want to structure your narrative. So after your motivation slide, talk about the data that you use. This part is the same as the last time. Talk about your sources. This one was a Kaggle data set, and you can say that as well. If anyone did any additional scraping or API or getting additional data from anywhere, mention that as well. And then a snapshot, like a very, very high level overview of what your data is. So in this example, you would say, all right, this was taken from Kings County, number of houses, maybe like the price ranging from however to however, nothing that needs a visualization to back it up. So after introducing your data source, talk about EDA. This EDA, I'm sure that a lot of you ended up doing possibly more than 3 to 4 pieces of EDA, I'm guessing. But here I would say the best visualizations to use will be any visualizations that are most relevant to your analysis or modeling. In a linear regression project, the most common visualizations you have are the scatter matrix, where you have the matrix with every variable plotted against every other variable. I will say be careful with the scatter matrices because you don't want the really big ones with many, many variables. Try and narrow it down to the relevant ones because very likely with that visualization, you're showing multicollinearity. So try and narrow down those scatter matrices to only the ones that are actually showing multicollinearity. It'll just be clearer on your slides. Same with last time, feel free to annotate, draw circles and squares and arrows to annotate just to make things a little bit clearer. And this can also be a couple slides depending on how much content you have. So that is pretty much I would say this part takes up maybe 2 minutes of your presentation. The bulk of your presentation, or I guess 3 out of 5 minutes, would be about the modeling. So this is where you would usually just present your final model if you didn't do it at the start, or if you already did it at the start, this is where you really take a deep dive into your final model. Also possible if you feel like you don't have enough to talk about, you maybe can talk about an intermediate one or your baseline model if you think it adds to your presentation. And with your model, you're not just going to show, hey, this is the final model, these are the coefficients, but also talk about really briefly in maybe bullet points, the feature selection and feature engineering that you did, because to an audience that wants to know about your model, that is relevant, because it's relevant what kind of features you're using to predict price, and what unique things that you did to your data set to create this model. So some very basic examples: eliminating variables based on p-values, removing collinear ones. If you created any interaction terms, if you created any of your own engineered features, mention that as well. Talk about scaling, transforming, but not in detail. Just say, I feel like for this part, you can just say, all right, I scaled this based on the distribution of the variable itself. It looked like it could use a log transform, therefore I log transformed. And then finally, you want to evaluate your model and interpret coefficients. So evaluate your model, talk about the R squared. How well does it fit your data? Don't forget to use the correct definition of R squared. I've seen quite a few, not quite a few, but I've seen a handful of presentations that don't use the correct definition of R squared. So just go back into your notes or go back into the lessons to find the right definition and make sure that's in your presentation. And also talk about R squared, talk about the p-values, if there are any ones that aren't 0, or if there are any that, like, I don't know, maybe you really decided to keep one specific feature that had like a 0.1 p-value. If you have a case like that, mention it too. Also, evaluate some of the coefficients. And I say here some of the more important coefficients. It really depends on context. So sometimes you could be just looking, all right, based on magnitude, which coefficients have the biggest number? Maybe you want to talk about that. But also it might depend on what the variable is. So depending on the variable, you might want to talk about specific things. Maybe you want to talk about square footage, or like anything that has to do with the structure of a house, like square footage, number of bedrooms, bathrooms. Those things are easy to say. As you go up by 1 unit, you're going to increase or decrease price by however much. Or if you have transformed coefficients, or not if you've transformed any variables, just remember when you're interpreting the coefficients for those, that they've been transformed. And then once you've talked about all of that, that's pretty much it. You just get into your summary and your conclusions. I would say for the summary here, you want to try as best you can to link back any insights or any like interpretations from your model back to your business case. So for example, in one of your interpretations, maybe you come up with, let's see, maybe having a basement, for example. Maybe having a basement really has an impact on like the price of a house. Maybe just all houses with a basement significantly have a higher price, regardless of size. Perhaps that's one of your interpretations. And in that, if your business case was to like, all right, I want to use this for flipping houses, you can just make that connection there, saying that like, all right, if your goal is to flip a house and make a bunch of money, have your house have a basement. That kind of example. If applicable, next steps. I think with most data science projects, modeling projects especially, there are a lot of next steps. So in here, literally just like list all the things that you didn't do, or the things that you could have done with more time. So for example, if you didn't try polynomial regressions, try that. I think a very, very common next step for linear regression projects is in the next mod, we're actually going to learn about other non-linear regressions. So that means that we'll be actually fitting models that are not linear. And maybe you can say as a conclusion, if your model didn't do very well, you could say that this data might not be well fit for a linear model, and possibly look into just other models. That's also the next step. And then finally, the thank you slide. This is the same as the last project. So resources that you use, link your GitHub repo, acknowledgements, and maybe you want to add your contact info. So this is the template. Any questions before I dive into the student example?
Not so much about the presentation, but when you were talking about the features for the data, you talked about kind of to mention if we include any variables with a p-value over 0. And I thought generally this project was with under 0.05.
Yeah. So yeah, it is one of the It's actually like it's not on the rubric, but it's in the prompt for the project on Learn that you shouldn't have any variables above 0.05. What happens is that in a handful of cases, depending on like whatever route you choose to like iterate your modeling process, sometimes I've seen cases where students have cut out so many features because of, I guess, the way they go about their feature selection. You end up cutting out a lot of features. And if you're trying to only predict price using like 2 or 3 features, that doesn't really make sense. So because of that, you reintroduce some features that might not be as significant, but in that case, like there's nothing you can do about it. Or this is where, you know, you can be a little more subjective with the science, because sometimes you really want to have a measure of, and this is of course not as scientific, but sometimes if you really think that the price of a house should have a predictor of something, like for example, you really think that the square footage has to play a role in the price of a house, maybe their p-value wasn't super high, maybe it was like 0.08 above like a 0.05, maybe something like that. You could argue that even though it's not very significant here, it still has a pretty good chance of being a significant feature. Does that make sense? So by right, in a perfect linear model, you don't have features above 0.05 p-value, but there are some cases where you can make exceptions. Either you really have no choice and you just need more features, or you really think that that's a feature that you want to include in your model. But I will say, like, models like that, not as scientific. Any other questions? Awesome. So this is linked in your guidelines. So is this student example that I'm about to talk through. So this is also a Mod 2 project on regression, but it's done on a different data set. And so this project was predicting the maternal mortality ratio of different countries based on a bunch of demographic information. So this presentation follows very much the structure of the template, but I just want to talk through some choices that were made. First, agenda, fine. Up to you whether you're going to add that or not. So this is one of the cases where the person decided to start with the results and just start by presenting their final model. So here you can see that, of course, this person was presenting, so there's a lot more that was said that's not in the slides, but they're presenting their model, the R squared, how well, the goodness of fit of the model. These are the assumption plots. So this is checking for heteroscedasticity and also normality in the residuals, and QQ plot. So that one's also normality of the residuals. And then this is just like showing that you can use these features to predict maternal mortality rate. So after showing, like, you know, the final picture, I think the idea of doing this style of presentation is like, all right, people are now intrigued as to like, how did you get to this model? So you go on that journey right after. Talked about the data, where she got the data from, how much depth and breadth was your data. So here, I think they had like 69 features for 216 countries. So 216 data points, about 70 features. And then talked a little bit about the data cleaning. I would say data cleaning is not that important to talk about, but I wouldn't spend more than like 3 sentences talking about it. And then here, just some definitions, because maybe not everybody knows what these features mean. I think that could be worthwhile. I know that there are some features in that Kings County data set that say like square foot living 15, like any of the ones with 15, I think like without reading what the variable means, you might need a definition. So if you decide to use one of those variables and talk about it, I would say have something like this where you explain what that means. She also had some quick EDA here. Here she talked about what she did with the missing data. Also scatter matrix, as I mentioned, just presenting that. And I think, if I remember correctly, she was talking about how some of these were distributed. And then she compared it to the baseline here. So baseline here, just talked really quickly about the differences in the models. So for example, here, baseline, nothing was transformed yet. Here, they transformed the target. More ADA to talk about interactions, because I think they ended up using, I think they might have ended up using interactions, but I'm not too sure. But yeah, this is an example of a presentation. I think you can kind of like pick out and see, I mean, use your own scrutiny, see what stands out to you and how you think you can use elements of this in your own presentation. But yeah, here, interpreted coefficients. I would say you don't have to interpret as much of these, maybe the ones that are most relevant to your context. But yeah, questions? Or like presentation related questions first, and then I'll stop the recording for any other questions.
So this presentation has to be as exhaustive as this, our presentation?
I would say this is a little more than average. For sure, this is more exhaustive than average. I would say more average presentations don't have like the second model. Usually you just have like perhaps the initial one and then talk about, maybe have like all of these steps on another slide or with your final model slide saying like what are the steps that you took to get from first model to your final model. I would say there's also a little bit more EDA than what's needed. Like for interactions for a non-technical presentation, usually you don't need to show this information. So yeah, there's definitely more on here than what's needed.
Okay.
Anything else about presentations?
Yeah, just
I think,
what is the, so
Go
what
ahead.
is the conclusion of this? I don't really see any conclusion or like what is the line?
Yeah, that's great. There's no conclusion here. I think this person probably like made the conclusions at the very end. Something to note, they also didn't really have a business case for this, which is actually, I mean, something that you all should have. This project was done like over a year ago, by the way. So I think, it's a little bit different, but overall structure quite similar. This one definitely has more focus on like the technical aspects, but for our presentations, what I want to see on next Monday is definitely more connecting it to context. But yeah, that was a really good observation. Any other presentation related questions?
The presentation is not the next Monday, like Monday after that, right?
Sorry, yeah, you're right. The presentations are the Monday after. So I'll be putting a message in Slack, but next week is actually your cohort break. So even though the project has to be submitted on Sunday, the cohort's on break. There will be no one-on-ones unless you message me first, and we can definitely still have a one-on-one. But I will assume no one-on-ones unless you message me. And then the presentations will be done the following Monday, which I believe is November 2nd. Let me double check that really quick. Yep, November 2nd will be presentation day. So on that cohort break week, if you decide to do any improvements to your project or change anything in your project, you just have to push it to GitHub and the changes will be reflected on the link. Anything else? All right, I will stop this recording here. And now, any questions? Oh wait, I didn't stop the recording yet.